All right, guys, this is Higgy. I know I'm a little dark here, but I'm going to run through this for you pretty quick. All right, the first two problems are finish the poster, finish the velocity, and the little spread thing that you did outside, the velocity speed thing that you did outside. I need both of those stapled together and turned in. Find your poster, put your paper, and staple both of those together and leave them in a stack up here in the front of the floor, in the front of the room like we've done before. All right, so stack them up according to your period. That's step one. All right, let's look at this first problem. A baseball is hit at an angle of 15 degrees. There's 15 degrees at 49 meters per second. 49 meters per second. How far does it travel horizontally? All right, so we're trying to find a horizontal distance. Well, to get a horizontal distance, I'm going to need the velocity and the time. I'm going to need a horizontal velocity and a time to do that. All right? Well, I don't know either one of these yet, so I've got to find them. The way I'm going to find my horizontal velocity is I'm going to use SOHCAHTOA. SOHCAHTOA, and that's adjacent, so it's the cosine. So I have 49 cosine of 15, and that should give me my horizontal velocity, and that's going to be, I'll punch in our little calculator here, 49, let me make sure I'm in the degree modes. I am, good. All right, 49 cosine 15. And now I've got to go down and hit classic because some goofball changed it. 49 cosine 15 equals 47.33 meters per second. That's my horizontal velocity. All right, so now I have my horizontal velocity, 47.33, but now I need my time. Well, to find my time, I need to get my vertical velocity, so that's going to be 49 sine of 15, and that's going to be my vertical velocity. So let's do that. 49 sine of 15 equals 12.68 meters per second. All right, so then I'm going to take that particular formula, and to find my time, I'm going to use my vertical velocity. My time is I got to find the formula. Time out a minute. So I walk over here, and I'm still talking to you. So you know me, I don't remember formulas, and I don't expect you to either. So I had to go get my little formulas. And my velocity then, if I'm looking for my time, is it's my final velocity divided by my acceleration. All right, so I know my acceleration is 9.8 meters per second squared. My final velocity was 12.68 meters per second. That's my vertical velocity. So I take 2.68 divided by 9.8 equals, my time is 1.29 seconds. All right, but that's only half the time from when it's falling. So I got to multiply that times 2. Time 2 is 2.59 seconds. So there's my time. 2.59 seconds. So 2.59 seconds times 47 times 47.33 equals 122.48 meters. And that's how far the ball, or the whatever that was, what was it? The ball was traveled horizontally. All right, so there's the first one. If I didn't do any mistakes, it should come out good. At least we followed the right process. That's that one. All right, let's look at this graph right here. This graph is a velocity time graph. That's the first thing I need to look at. All right, describe what is happening at each line segment. Well, right here, my velocity is going from 0 to positive 10, so my velocity is increasing, or it's accelerating positively. All right, from B, my velocity stays at 10. At plus 10, it stays, so my velocity is constant at 10 meters per second. And then from here, this one's a little tricky. First of all, my velocity is decreasing. I'm going from 10 to 0 right here. So my velocity is decreasing from 10 meters per second to 0. Then it is increasing negatively from 0 to negative 10. So really I have even though my slope is negative, I'm having a decreasing positive acceleration, decreasing positive, but then when it gets to 0, it's speeding up. So I'm going backwards. So what's happening with this thing right here is it's moving at 10 up here, and then it slows down to 0, and then when it gets 0, it starts backing up and going faster backwards. That's what's going on right here. All right, and then at D, it's a constant negative 10 meters per second velocity. All right, so you have to read the graph. You have to look at it and see what it's saying and pull the information. The first thing you want to do is identify, this is distance over time. That's always time on the bottom. All right, so this one's a little bit different because now we're talking about distance. We're not talking about velocity. So here I'm going from negative 10 position, negative 10 to positive 10. So negative 10 position to positive 10 to positive 10 position at a constant velocity. And the reason I know it's a constant velocity is because it's a position time graph and my line is straight. And the line is going to tell me, the slope of the line is going to tell me that it's a constant velocity if it's a straight line. All right, then up here it's not moving because it stays not moving at position 10. At position 10. All right, from here it's doing just the opposite of what it was doing there. It's plus 10 to minus 10 at a constant velocity. All it's doing is going from plus 10 to minus 10. D, it's a constant velocity, not constant, it's not moving at negative 10. And then we don't have that one, but we do have E, and that's not moving at 0. At position 0. All right? So it's just reading the graphs. All right? Now the big issue on the front page of that thing. So let's look at the other page. The back side. Define these terms. Speed. Speed is just distance divided by time. Velocity is speed with a direction. And that means plus or minus. All right? Acceleration is a change in velocity. Distance is when we have distance displacement. Distance is actual travel distance. And displacement is from start to finish straight line. You can think of it that term. In terms of just where you started to where you end, the quickest place between 2 points is a straight line. Scalar is just a number, some quantity. And vector is a scalar with direction, which is positive or negative. All right? Describe real life situations for the following. Positive velocity with no acceleration. Positive velocity, no acceleration. A car traveling at 10 meters per second, constant. Because there's no acceleration. It's not changing its speed at all. Hopefully my pen still works. All right, negative velocity, positive acceleration. We're going to put a car traveling positive direction there. Negative velocity, car traveling backwards or negative, slowing down. Because the velocity is negative, telling us that it's going backwards, but there's a force acting on it the other way. So I have a car that's traveling backwards, but there's a positive push this way, and it's slowing me down. So car traveling backwards, slowing down. No velocity, negative acceleration. That could be a ball about to fall. At the top of it, that's where our initial velocity is 0. So you throw something up in the air when it goes at the top. Remember, there has no velocity, but it still has an acceleration. Gravity is still trying to pull it down. So it's a ball about to fall. It's at the top of its flight, at the top. All right, negative velocity, negative acceleration. A car going backwards, like up here, car traveling backwards, negative velocity. But this had positive acceleration. This one has negative. So this is car going backwards, speeding up. Because the car is going backwards, that's a negative direction, but there's also a negative acceleration pushing it, speeding it up. And increasing velocity with no acceleration, you can't have that. That doesn't work. Can't do that. If the velocity is changing, you have an acceleration. It could be positive or negative. All right, explain why and what formulas you would use to calculate what it would take to hit a giant in the head with a slingshot. All right, so let's say that you are standing here and the giant is here. It's a really big giant. All right, so you need to know this distance. You need to know a vertical distance. And you need to know what angle to fire this thing out to hit him. And you need to know what velocity. There's a whole lot of things that you could use here. So to find the vertical distance, I need to know how long it would take a ball fired to get to the top. All right? Well, to do all of this stuff, we can think about it in a trillion different ways. We need to know how fast to fire it so that it would reach him and bop him in the head. Well, if the distance formula, the vertical distance is equal to, let me pull out this little formula, make sure I get it right for you, is if I know the final velocity, it's going to be the square of the final velocity